Hello and welcome to this brief presentation about the forthcoming series of lectures on the Physical Reality channel. The first of the lectures is titled, An Introduction to the UP Hypothesis. It is divided into 4 parts. Part 1, Introduction and Definitions, lays the ground for the logic on which the hypothesis is based. The speaker begins by outlining, in broad terms, what the UP hypothesis is about. He then talks briefly about the concept of space fabric, and touches on its relevance in the theories of relativity, and in quantum field theory. In general relativity, time is considered an extension of space. It represents the fourth dimension of space, and the two, that is, space and time, are coalesced into a dynamic stage, referred to as space-time. Although the speaker refers to space-time, he does not consider the nature of time in this lecture. Doing that at an early stage would introduce a host of complexities to the definition of space, without realizing any benefit from it, in support of the hypothesis. The complexities arise because of the dynamic nature of space, which gives rise to time as a perceptible phenomenon. In fact, considering space and time is what we regard as energy. Getting into the entanglement between the nature of time and energy would certainly divert attention away from the intended flow of the lecture. Therefore, to begin with, space is considered the stage on which stills, as well as dynamic frames of physical reality could be played. Then, later on, the dynamics of the stage itself are introduced as part of the play. After considering space in quantum field theory, the speaker considers the need for defining space mathematically, but in physical terms. He explains the problems associated with using theoretical points to define space. Theoretical points are assumed to have no dimensions, and the space defined by them is referred to as a phase space. He reveals the extent of confusion caused by that assumption in the mathematical modeling of systems, including subatomic particles and their interaction with quantum fields. He then explains the relative nature of spatial dimensions from the perspective of the observer. That is, from the perspective of the mathematician. He concludes Part 1 by explaining the physical significance of singularities, both physical and mathematical, and their relationship with infinity. Part 2, Observations and Interpretations, covers 2 important observations, both of which are cosmological. Those observations are used to draw conclusions as to what must be taking place in the fabric of space at a level much lower than that of the elementary particles. That is, at the level of the elements of the fabric of space proposed by the hypothesis, the size of which is of the order of magnitude of the Planck length. The first observation is the effect of matter on space geometry, which refers to the curvature of space by matter. The second observation is the expansion of the universe. From those 2 observations the speaker draws conclusions as to the structure and mechanics of matter particles and nature of energy, including dark energy. With mass and energy being considered 2 sides of the same coin, the speaker defines each of them independently, and interprets Einstein's famous equation, E=mc² in light of those definitions. He concludes Part 2, by defining temperature, and cosmic microwave background radiation in terms of the dynamics of the fabric of space. In Part 3, the UP hypothesis. Having defined a space fabric, and identified the 2 mechanisms by which matter particles could possibly acquire and maintain mass as stable particles, the speaker introduces an outline statement of the hypothesis. In the process, he covers, in physical terms which could be pictured mentally, the phenomenon referred to in particle physics as the Higgs mechanism. Although, as a consequence of the hypothesis, there are other mechanisms by which particles could develop and acquire mass, those mechanisms do not result in stable particles. Although not covered in this lecture, they will be covered in a future one. The speaker then goes on to explain, also in independent physical terms, the properties of matter particles, from classical and quantum mechanical perspectives. The display of some stills and animation clips clarify the concepts presented, and help explain how matter and energy develop from the proposed fabric of space. At this stage of the lecture, members of the audience with background in quantum mechanics and relativity should be able to appreciate the reason behind the apparent conflict between the two theories. In a layman's terms, the conflict relates to the smoothness vs chunkiness of space. The speaker clarifies the reason behind the apparent irreconcilability of the two theories. In the final part, Part 4, Applications of the Hypothesis, the speaker applies the hypothesis to some hitherto unanswered questions in physics. He uses it to explain the reason behind the unexpected behavior of galaxies and galactic clusters. A reason which has thus far eluded physicists and led to the prediction of the existence of dark matter. The speaker then turns to string theories, and explains their relevance in particle physics. He subsequently identifies the reason behind their dimensional diversity, and reveals the reason behind the need for additional spatial dimensions to explain physical reality under those theories. Finally, he pinpoints the layers of dimensions within the structure of subatomic particles as predicted by the hypothesis, which according to the quintessential of all string theories, namely, the M-theory, are 11 dimensions in all, of which 9 are spatial, and 2 are time dimensions. End of lecture.